All right, on to more fun. Let's go ahead and now finally chip off that tertiary edge. We have 1 point. We have a sphere ready to go. Now it's time to copy the points. However, instead of building this out from scratch, we already have a setup that basically does the same thing, and it's right here. So let's literally copy all those nodes, Control C, set this to manual, and get rid of all of these connections. Now we have everything we need to adjust to what we want. We don't really need to get the normals, but we will do a attributes randomize on those normals so that they just face in different directions. And we'll now say n with a distribution that's inside sphere so that we're going 360 degrees. So that goes on the points, like so. There's variant, there's p-scale. Here is variant as well via the connectivity SOP. That gets copied to points. We need to Boolean against our original geometry. So let's take this all the way up here to the larger piece, like so. We now set the name so that all these new tertiary points basically share the same name as the secondary piece. And we finish all that off with a connectivity. And that's rerun with all the new stuff in mind. And now we want to add T for tertiary. Last but not least, this group, we need to change this from primary piece group to something else. Let's go here to the Boolean and just call this our secondary piece underscore group. And we'll just Control C, Control V. Gotta love it when you don't have to think so hard. So now we have that. And this should all work properly. If we do an exploded view, and we set this to a point on the piece elements, and then we turn this back to auto update. Let's see what happens. All right, so visually, this all looks great. But if I press D for display, and I already have this name marker set, our name is not proper. Look at that. Something's wrong. Why is that? Well, because we didn't hook up the second input here for the set name. We now need to go up here, and that fixes the whole thing. So our main piece does not have the dash T. Our tertiary piece now does, and life is great. Okay, so with that being the case now, let's set a compiled block. And with luck, we won't have to think about it. It'll just be multi-threaded and amazing. So we are going to go top to bottom. We're going to create another begin block before the lab sphere. So let's just go down here. So before anything happens, we can just, yeah, we can do that. And then also create another block for the begin. Just like you saw in the last loop. Okay, and just to make this work properly, we need to be sure that we go to that for each begin and set this to fetch inputs. Really important that you do that, otherwise this won't work. We do that, again, multi-thread when compiled. Also, for the set name here, be sure that we're using the second input to read the name, if I haven't already said that. And at the very end of this, now we have something that should be good. Let's turn off single pass and see what that gives us. It goes really, really quickly, and we have a great looking result. Now we have all these tertiary sized pieces. We still have the secondary pieces. If we want to turn down the size of that tertiary scale, it's very easy to do that. We just need to take that piece scale a little bit lower. Let's say 0.5. And it's a very easy way to control the tertiary scale. If you want to include more tertiary pieces, we could try turning up the scatter to maybe, let's say, a total count of 3, and that might do the trick. Also, if you do 1, if I haven't said this, it won't work because the copy to points wants 2 points, for some reason. So you need to set that to 2. But anyway, that's that for the tertiary stuff. It's really a lot of the same techniques that I just taught you before with the secondary fracture. And just to double check that everything is working properly, let's zoom in right here, press D for display, take a look at the name, and let's see if we can just maybe highlight a couple of these, blast them like so, and zoom in a little bit more. Here's a secondary piece. We don't have a tertiary suffix. There's a tertiary piece. We do have a tertiary suffix. And while I'm here, just double checking my work, we have a bunch of n-gons. So let's also use a divide sop right after that Boolean and before we read the name. So right here, and that should fix our topology issues. Okay. So back to our exploded view, everything is still alive. You might see some errors about the unshared edges. At this point, I'm not terribly concerned about it. That might come around to bite me later, but everything seems to be in working order for the most part. Also, don't forget about the tiny little pieces over here. Almost forgot about that. Want to merge in those small pieces too at the very, very end of this whole thing. So we take this guy and we take our smaller pieces like so, and then that becomes the final result. And there you go. Now we have everything we need for a much more detailed simulation. And just for fun, here is a play blast of what we just did. The tertiary adds just another level of interest in the scale of everything. I also like how we have some more uniformly circular pieces. Sometimes with these simulations, you can, especially the Booleans, you can have pieces that are too like jagged or not round enough. So having these tertiary pieces kind of helps break up the shape as well. That all is looking good for now. In the next video, let's mess around with some bullet attributes, followed by animation.